Hi there, geometry students. It's Mr. Pounce. Here's a video for the Chapter 3 practice test or Chapter 3 review, which is all about parallel and perpendicular lines. Just in case we weren't able to have a study session, you can utilize this resource to help you through the practice test or the review. So we're going to kind of go quickly through some parts of this. The first part says describe each pair of segments in the prism as parallel, skew, or intersecting. Now remember, parallel would be in the same plane and never intersecting. Skew would be in different planes and never intersecting. And intersecting obviously would be they cross each other's paths. So segment BG, if I'm looking at segment BG and segment AB, so here's AB, and segment BG is over here. Well, those intersect at the point in B, so those are intersecting. We'll just do I for intersecting, S for skew, or P for parallel. All right, now we've got segment EJ and BC. I don't think they intersect because they don't have a common point in their letters, but we'll just look. EJ would be right here, and segment BC would be way back here. Now they're not parallel. You can tell they're not in the same plane, but they're also never going to intersect. So those are going to be skew lines. All right, segment AE and FJ. We'll do green here, AE and FJ. Those are in the same plane, and they would be parallel, assuming that would make a rectangle. So they would be parallel to each other. And the last one, CH and AE. Oh, we have AE again. AE and CH. All right, those are not in the same plane, and they're also not intersecting, so they are skew lines. They're not parallel either. All right, part 2. Name the parts of the pentagonal prism shown above. All right, we're still using the same thing. I'll erase these parts. Three segments that are parallel to segment EJ. Segment EJ. So we have segment EJ. I could say, first of all, segment DI. That makes a parallel line. Segment AF. And then based on kind of like the transitive property, we can figure out that segment BG would also be parallel if you were to make a plane that goes from EJ to BJ, or sorry, BG. And also we could figure out that CH. So I have 4 different ones. You just have to name 3. Number 6 says 3 segments that intersect segment DC. Segment DC, we're dealing with this one right here. So they have to have a common point with DC. So we could say BC, segment BC. We could say segment ED. We could say segment CH. We could say segment DI. Oops. And I think those are the only 4 that actually intersect with segment DC. You'll need to name 3 of them. All right, number 7 says a segment that is skew to segment IH. So do that in blue. So not in the same plane, but also not parallel to it. So we'll say AF. That one would be an acceptable one. It's not in the same plane. It's also not parallel by any means. So AF. EJ would work. BG would work. And I think there are more too. We're just going to name those 3. You only have to name 1. All right, then number 8 says the plane that is parallel to plane EAB. So plane EAB is actually this back one. There's only one plane that's parallel to EAB, and this would be the opposite side. And you could label it different ways as long as you have 3 of the points. You can say FGH. You can have any of those 3 points on that pentagon. Alright, next section, finishing up page 1, it says identify each pair of angles as alternate interior, alternate exterior, same side interior, or vertical. So we have 4 different options. These are crucial to know these different angle pairs. So even if they're not parallel, you can still have those angle pairs. It just won't be congruent or supplementary. But number 9 says angle 10 and angle 16. So if we're dealing with angle 16 and angle 10, those are on opposite sides of the transversal, if this is our transversal. They're on the interior of those two lines, so those would be alternate interior angles. All right. Angles 5 and angles 1. So 1 and 5. Looks like they're on the same side of the transversal, but they're not both on the inside. If this is our transversal, they're actually in corresponding spots. That's not even one of the options. Angles 1 and... Oh, that's because it's angles 1 and 15. I was going to say they would be corresponding angles. Let's look for 1 and 15. Those are alternate exterior if this was our transversal. All right, angles 6 and 8. We'll do in green here, 6 and 8. Well, those are just opposite of each other on the same. So those two angles, 6 and 8, are, of course, called vertical angles. And lastly, angles 3 and 6. So we have angle 6 again. We have 3 over here. Looks like they're on the same side of the transversal, and they're on the interior of those two lines, so they are same side interior. All right, knowing these angle pairs will help with other things as well. Going forward, let's go to page 2. It says number 13, find the measure of each numbered angle. So we'll do number 13. Ooh, we gotta find a lot of them here. Angle 3 we should be able to figure out because that's a linear pair with 140. So that would leave us, to get to 180, that would be 40 more degrees there. If those two lines are parallel, then 3 and 4 should be congruent because those are alternate interior angles. So that one's also 40 degrees. These are also parallel. If this one is 90 degrees, then this one is supplementary, so that's 90 degrees. And this is vertical, so that's 90 degrees. So measure of angles 1 and 2 are also 90 degrees. Those are going to be right angles. There you go. Number 14, we have two different sets of parallel lines, so that's a parallelogram there. And to start us off, well, there's a couple different things. You can do 1, you can do 2, you can do 4, all at the same time, just from this number, angle 33. So the measured angle 1, that's a linear pair with 33. So 180 minus 33 would get me to 147. All right. Measure angle 2, that looks like it would be corresponding with 33. So that one is also 33 degrees. Measure angle 4 is alternate interior with the 33. So measure angle 4, put that up here, it's going to be 33 degrees. And then if we look at 2 and 3, so measure angle 3 would have to be same side interior with angle 2, so those are supplementary. So that would leave us with the 147 again. All right. Going down to number 15, find the values of x, y, and z. All right, so we need to find x, y, and z. We have the 115 degrees here. Hopefully you can tell the measure of angle x, or x, we don't have to say the angle x because it says x degrees there. You can just say x should be equal to the same thing as its vertical angle, which should be 115. Y, we'll leave that for a second, but z, that's a linear pair with both of those two angles we have there. So 180 minus 115 would be 65 degrees. And then angle y, you can figure out a couple different ways. If we know that z is 65, and we know that the other one inside there is 84, we can subtract those two from 180. You can also tell that this is the exterior angle, so we know that 115 equals y plus 84, because those two added together would have to get to 115. So I think that would leave it with 31. All right. All right, we're moving forward here. We got 3 more on this page. Well, actually, okay, number 16. It says find x so that a and b are parallel. So for a and b to be parallel, these two angles that are on the same side of the transversal and on the interior would have to be supplementary. So if we can say that they're supplementary, we can say that 5x plus the x plus 12 would add up to 180. So you have 6x plus 12 equals 180. When you do your inverse operations to solve for x, you have 6x equals 168. Divide both sides by 6. X equals 28, I think. I can check that on my calculator if you don't trust me. I just did that in my head, so I could be wrong. 168 divided by 6 is 28. Alright, so x would have to be 28. Now number 17, we want A and B to be parallel as well, but there is no A and B. So we're just going to assume that all three we want them to be parallel. So this one would go here. So ultimately, if they're all parallel, we could figure out that 3y minus 11 plus 56 would be supplementary, because 3y plus minus 11 would have to be equal to this angle right here, and that's supplementary to that one. So we could say that 3y minus 11 by 11 plus 56 equals 180. Hopefully this will work out. So you have 3y plus 45 equals 180. You subtract 45 from both sides, you end up with 3y equals 135. Divide that by 3, you get y equals, what is it, 55? Wait a minute. 135 divided by 3 is 1. Oh, yeah, 145, sorry. Or sorry, 45. So y would be 45. You can do the same thing with the other two. We can ultimately say that 56 would have to be congruent to this angle right here, which is supplementary to 4x. So then 56 and 4x would be supplementary, meaning they'll add up to 180. So 4x plus 56 equals 180. 4x, when you subtract 56 from both sides, you have 4x equals 124. And you divide that by 4. 124 divided by 4. Whoops. Would be 31. So that would be 17. We got x and y. Number 18, you can take a big X through your problem because we did not talk about how to construct um, uh, parallel lines to that point or perpendicular lines. That section we skipped, and that is something you don't have to know how to do. If you would like to know how to do, you can always ask me or you can look it up. But before we go on, let's take a little joke break here because there's a lot going on in one video. So my joke is, what does a skeleton, since it's around Halloween time, what does a skeleton order at a restaurant? Well, skeleton orders spare ribs. Get it? Spare ribs, it's a skeleton. Ha 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 ha. If you didn't like that joke, you can ignore it. Otherwise, you can tell it to everyone you know. But we're going to go on to page 3. Page 3, now we're dealing with a lot of things with the slopes of a line and linear equations. So I might not go through every single one, especially for numbers 19 through 22, because they're all very similar. You just need to know how to use the slope formula, which is y2 minus y1. Remember, there is a minus sign. Even if there's negative y1, you'd have minus a negative. That's what some people are leaving out. Over x2 minus x1. So for instance, let's do number 19. Let's use a good one. Our y2 would be our second y value, which is 12. we're going to subtract the first y value, which is negative 4. So there we have minus a negative number. You can have that. And we'll do second x, which is minus negative 2. Again, we can do that. That just turns these into plus. So we would have 16 over 10, which would reduce to 8 over 5. I'm going to leave it like that. If I did that correctly, I think that would be what you'd end up with. Alright, let's skip to number 22 then. The slope would be the second y, which is 14, minus the first y, which is negative 2. Whoops. All over the second x minus the first x. We get plus here. So 16 over 0. If you have a run of 0, it means it's going to be a vertical line. And you can't divide anything by 0. So that means that makes it undefined. Alright? Alright, we'll skip numbers 20 and 21. We're going to go on to number 23 and 4. Given each set of points, determine if A and B are parallel, perpendicular, or neither to C and D, to line CD. So, if you remember, when we talked about parallel and perpendicular lines, all you have to know is the slope. For the slope to be parallel, they have to have the same slope. For them to be perpendicular, you'd have to have opposite signs, and they'd have to be reciprocal slopes. So we'll just do number 24. We'll do one of those. So if we find the slope for AB, the slope would be 0. Whoops. Not sure what happened there. 0. So we're doing A and B now. Minus 8. 4 minus 0, which would be equal to negative 8 over 4, which would be negative 2, or negative 2 over 1. The slope for, we'll do this one in green, CD, the slope would be 3, the second y, minus 1, over 3 minus 2, which would be 2 over 1. Alright, those are our two slopes. Now, they are definitely opposite signs, but they're not reciprocals. If they were reciprocals, they would be perpendicular, but they are neither in this case, neither parallel or perpendicular. I spelled neither wrong. N-I-T-H-E-R. They're neither perpendicular nor parallel. Alright, let's go on to the next section. Name the slope and the y-intercept of the graph of each equation. So sometimes maybe it just helps you to actually graph them. But if you get it into slope-intercept form, you should be able to find both the slope and the y-intercept, no problem. So with those first two, we just have to solve for y. So like for number 25, I'm going to subtract 2x from both sides. You end up with just 3y equals negative 2x plus 12. And you divide both sides by 3. You end up with y equals negative 2/3 x plus 12 over 3, which is 4. So then for number 25, your y-intercept is positive 4, and your slope is negative 2/3. There you go. So that would be how you do it for, similarly for number 26. I think if you were to do that, I could figure out that the slope is going to be 3/4. The y-intercept is going to be 2, in case you want to check that. 27 and 28 are slightly different. I would consider graphing it just to picture it. If x equals 4, there is going to be no y-intercept. That means your graph looks like this. And here's 4. Your graph is just going to always go through the x equals 4. It's never going to cross the y-axis. So no y-intercept. And the slope is up and down, so it's undefined slope. All right. Now, y equals -4 is a little bit different. I'll graph it over here. It's going to kind of look like this. So you're going to cross the y-axis at -4, so the y-intercept would be -4. But the slope is just going straight across, so it's a slope of 0. So it'd be like y equals 0x plus -4. All right? So that is page 3. Let's finish up some of this graphing stuff with page 4. I'm going to graph a few equations, and then we'll just write a couple equations, and then we have a few proofs at the end, and we'll go through. If you need to take a break, feel free to pause it and break it. Otherwise, we're just going to carry on here. Graph each equation. Most of you prefer to put it in a slope-intercept form, and so do I. That makes things so much easier in my mind. So if I put number 30 in a slope-intercept form, I just have to divide both sides by 4 to get the y by itself. So I have y equals 12 over 4 is 3 over 1x plus -2. So if I graph that, I have my y-intercept at -2. Hope you can see that. I'm going to go up 3 and over 1. Up 3 and over 1. Up 3 and over 1. Draw the line through those points. It's going to look something like that. If you could draw a more straight line than I can. Let's skip to number 32. So I'm going to subtract 1/2 x from both sides. So I have 1/4 y equals -1/2 x plus a -1. And then to get the y by itself, I have to multiply both sides by 4. So I have y equals, wow, my handwriting is looking bad today. So we'll erase that. Y equals times 4 would be -4 over 2, which would be -2 over 1, x, plus times 4 would be -4. So this one we're going to start at -1, 2, 3, 4. We're going to go down 2 and over 1. Or we can go up 2 and back 1. That'll actually work better for this one because of where we're starting. So it'll look something like that. My line is not good, but that's how it would be. Number 34, we'll just cross it. The y is -3, 1, 2, 3, and it's going to go only that direction. Horizontal, no slope there. All right, going on to the bottom of this page, numbers 35 and 36. Write an equation in slope-intercept form of the line satisfying the given conditions. All right, you know what? You can use point-slope form if that helps, and I'll give you a reminder. The point-slope form is y minus y1 equals m times x minus x1. And those points that we'd be plugging in would be for the x1 would be the x value, and the y1 would be the y value, and then the slope. Okay? So number 35, I would use that. You don't have to. You can plug in it for slope-intercept form and solve for b, and then put that back in. But for right now, I'm going to use point-slope form. I'll plug in y minus the y value is 3 equals the slope of 5 times x minus the x value of -2 minus -2, which would be x plus 2. All right, if I were to distribute and then add 3 to both sides, so we'd have y minus 3 equals 5x plus 10. So add 3 to both sides. End up with y equals 5x plus 13. All right, and then number 36, we're going to find an equation parallel to that passes through that point. So we're going to have to first figure out what the slope is so we can know that it's going to be parallel to that. And then maybe plug back into point-slope form again. So I'm going to add 4x to both sides here. I get 2y equals 4x plus 18. When you divide by 2 on both sides, you get y equals 2 over 1x plus 9, or 18 over 2, which is 9. So our slope has got to be 2 over 1. And maybe this time we won't use point slope form. This time we'll use regular slope-intercept form. And I'm just going to plug in that point in for the x and for the y. So y equals mx plus b. We'll do 4 equals 2 over 1 times the x is 1 plus b. So this is going to be 2 over 1 times 2. This is going to be 2. I'm going to subtract 2 from both sides. So that's 2. Subtract 2 from both sides. The b equals 2. Now we've got our b, we've got our slope. So y equals 2x plus 2. Alright, there's our equation in slope-intercept form. Hopefully you didn't get lost there. Feel free to pause it and go back and look at it again, or do it a different way using point slope form. Now these last 2 pages, I don't know if I'll go through all 3 proofs. I think there's 3 of them. I'll maybe go through 2. Oh, there's 4 of them. Oh no, 37 is another one like that. We just have to do it perpendicular. We're going to skip number 37. But there are 3 proofs. I think I'll go through 2 of them. And maybe I'll just do 38 and 39. Maybe I'll do 40 really quick, but I won't explain it while I go, because this video is getting kind of long. Number 38 says, complete the proofs. So we have given, that's always our first step, you know. So line L, which is right here, is parallel to line M, which is right here. And line N is parallel to line P, and that would be N and T. So that tells us a lot. If we know that these are parallel, we know that these are parallel, we know a lot about angle pairs then. Alright, that's given. Now, our goal is to get to angle 14, it can be congruent to angle 8. So if we're dealing with angle 14, I'll circle that one, and angle 8. So we want to somehow get from angle 14 to 8 or 8 to 14. So we're going to have to do stuff with those angles, is my hint for you. So why don't we just start with angle 8. What is angle 8 congruent to, if we know that those lines N and P are parallel? Well, we could say it's congruent to 10. We could say it's congruent to 12. I mean, we could say it's congruent to 6, but I think that's only going to add a step. But right now, I'm just going to say it's congruent to angle 12. And that would be because of the corresponding angles theorem. So the corresponding angle theorem, that says if 2 lines are parallel, then corresponding angles would be congruent. So that's where we get 8 and 12 congruent to each other. Our next step, well, we can label these. 8 is congruent to 12. Again, we're trying to get to angle 14, so you know what? We're actually there already, because angle 12 is congruent to angle 14. If you know your angle pairs, those are alternate exterior angles. It's the alternate exterior angle theorem. They didn't quite prove what we wanted to prove yet. But from that, if angle A is congruent to 12 and 12 is congruent to 8, then we could say that 8 is congruent to, if 8 is congruent to 12 and 12 is congruent to 14, then angle 8 would be congruent to angle 14, because that is transitive property of congruence. And that's not quite what we wanted to prove yet, so we technically have one step left to say that angle 14 is congruent to angle 8, and that would be reflexive. Oh, no, not reflexive. I apologize. Not reflexive. Symmetric. The symmetric property of congruence. And now we proved it. And now we give ourselves a real big smiley face, because that is correct. Okay, and now there are different steps you could do. You could go from, like we said, angle 8 would also be congruent to angle 10, and then we could do 10 to 14, so we could flip that around a little bit. We could throw in some vertical angles if you'd like to. There's multiple different ways to do it, so don't feel like this is the only way to prove what we need to prove. I will do one more, and that will be number 39. Number 39, I'm going to use purple, because I'm feeling purple. You know that line L1 is parallel to line L2. So right here, this is parallel to this. We're trying to prove that the other two sets of lines are parallel. And we have that 1 and 2 are congruent. Okay, that's interesting. That's given here. That was weird. Whoa, 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 whoa. Everything's going crazy here. There we go. So that's given that angle 1 is congruent to angle 2. Oops, no, I'm skipping steps. This video is definitely getting too long even for me. If we know that L1 and L2 are parallel, we can say something about angle 1 and angle 3. You can say that those are congruent. And I'm actually switch it and say that angle 3 is congruent to angle 1. And that would be because those are corresponding angles. That's the corresponding angle theorem. And then we can also say that if angle 3 is congruent to angle 1, and we said that angle 1 is congruent to angle 2 up there, then angle 3 is also congruent to angle 2 by the transitive property of congruence. Now, this is, maybe you didn't realize why I wanted to prove that, or why I wanted to get to that, but the only things that we have to prove that lines are parallel are the converse of the alternate interior angle theorem, the alternate exterior angle theorem, the corresponding angle theorem, and the same side interior angle theorem. And if the three angles that are labeled are 1, 3, and 1, 2, and 3, if we want to prove that A and B are parallel, we need to deal with angles 2 and 3, and those would be corresponding angles. So if we can prove that those are congruent, like we just did, then we can prove that the two lines are parallel, because that would be the converse of the corresponding angles theorem. And that's what we're trying to prove. So we proved it using the converse of the corresponding angles theorem. So big smiley face there. All right, we're going to end it at that. That was enough for you. Hopefully that helped. Hopefully you're able to check your work and able to study from that now. And maybe it answered any questions that you had. Feel free to ask any questions of me at school as well. But until next time, we'll talk to you later.